Hello and welcome to a video presentation on the order of operations. Here's what you'll learn: how to use the order of operations to solve numerical expressions. First of all, what is order of operations? Well, the order of operations is the list of rules we follow to solve numerical expressions. If people didn't follow a set of rules for solving math problems, different people could come up with different answers. Here's an example of why the rules are important. What do you get when you solve the following expression? Go ahead and take a few seconds now and solve it. Did you get 50? Or did you get 32? See, if you added 2 and 3 first to get 5, then multiplied by 10, you got 50. But if you multiplied 3 and 10 first to get 30, then added the 2, you got 32. So which is correct? Well, the correct answer is 32. Fortunately, since we have rules for solving math problems, everyone who knows the order of operations will get the correct answer, 32, every time. Most people learn the order of operations using the letters below and a cute little mnemonic or memory saying to help remember them. Do you remember what PEMDAS stood for? It stood for Please Excuse My Dear Aunt Sally. And we used this sentence to remember we should always look for parentheses first. Then we should look for exponents. Then solve multiplication, followed by division, then addition, followed by subtraction. But the 6 steps of PEMDAS can be a little misleading. You see, it implies that multiplication is always completed before division, and addition is always completed before subtraction. But that's not always true. So I'm going to show you a 4-step method that works every single time. Learn these 4 steps and you'll be solving math expressions like a pro in no time. Here they are. Step number 1. Perform operations within parentheses or other grouping symbols like brackets first. Step 2. Evaluate all powers or exponents. Step 3. Perform multiplication and division in order from left to right, just like you were reading a line of text in a book. And step 4. Perform addition and subtraction in order from left to right. That's it. 4 simple steps. Let's solve some expressions. Let's solve the following expression, first of all, by rewriting it. 30 minus 12 divided by 4. Step number 1, remember, was look for grouping symbols. Do we have any? No grouping symbols. Move on to step 2. Are there any exponents? Nope, no exponents in this problem. Move on to step 3. Is there any multiplication or division? In fact, there is one problem. It's 12 divided by 4. So we solve 12 divided by 4 and we get 3. Rewrite our expression now as 30 minus 3. Is there any more multiplication or division? The answer is no. So move on to the last step. Is there any addition or subtraction? In fact, there is. There's only one operation left. It's 30 minus 3. So when we solve that, we have the answer to our problem. It's 27. Let's try another example. Solve this expression. Let's write it down first. 36 minus 18 divided by 2 times 3 plus 8. Do we have any grouping symbols? No, we don't. Are there any exponents? Nope, don't see any exponents either. Move on to step 3. Is there any multiplication or division? In fact, there is. There are 2 of those operations. We have 18 divided by 2. And we have 2 times 3. So which one are we going to do first? Well, remember, we do them in order from left to right, just like reading a book. So we're going to do 18 divided by 2 first. Let's rewrite the expression, and we're going to replace 18 divided by 2 with 9. So now we have 36 minus 9 times 3 plus 8. Is there any more multiplication or division? Yes, there is. We still have right in the middle 9 times 3 to solve. 9 times 3 is 27. Rewrite the expression. We have 36 minus 27 plus 8. Any more multiplication or division? Nope. So go on to step 4, any addition or subtraction. In fact, that's all that's left. We have two operations like that, 36 minus 27 and 27 plus 8. Which one are we going to do first? Once again, the order of operations tells us to do them in order from left to right like reading a book. So we'll do 36 minus 27 first. That gives us 9, so we'll rewrite the expression as 9 and bring down the plus 8. Is there any more addition or subtraction? Yes, there is. One more operation. It's addition. 9 plus 8 has to be solved, and our final answer to the problem is 17. Let's solve this expression. Write it down. 9 plus 6 to the second power times 10. Are there any grouping symbols in this problem? No, there are not. Are there any exponents in the problem? In fact, there are. We have 6 squared, or 6 to the second power. So we have to do that next. 6 squared is 6 times 6. So we're going to replace that with 36 and rewrite the expression. We have 9 plus 36 times 10. Are there any more exponents? Nope, we're done with those. Move on to step 3. Is there any multiplication or division to be done? Yes, there is. We have 36 times 10 that we need to solve next. 36 times 10 is 360, so we rewrite the expression as 9 plus 360. Is there any more multiplication or division? No, there isn't. Move on to the last step. Is there any addition or subtraction? In fact, that's all that's left. One step. We have an addition problem. It's 9 plus 360. We solve that and we're done. The answer is 369. Let's solve this expression. Open parentheses 8 plus 6 times 7, close parentheses, times 25. Do we have any grouping symbols? In fact, we do. We have a set of parentheses around 8 plus 6 times 7. So we have to work in the parentheses first. Now within the parentheses, are there any exponents that we have to deal with? The answer is no. Move on to the next step. Is there any multiplication or division within the parentheses? Yes, there is. We have a multiplication problem of 6 times 7. So we solve 6 times 7 and replace that with its answer, 42. Now we have open parentheses, 8 plus 42, close parentheses, times 25. Is there any more multiplication or division within the parentheses? Nope, we're done with that. Move on to step 4. Is there any addition or subtraction within the parentheses? In fact, that's all that's left inside is an addition problem. It's 8 plus 42. We know that's 50, so we'll rewrite our expression now as 50 times 25. Is there any more addition or subtraction within the parentheses? In fact, there isn't. We've done everything within the parentheses, so we have no more parentheses to deal with. So now, since we've completed the parentheses, we do the last operation, which is 50 times 25. 50 times 25 gives us our answer, 1,250. Let's do one more problem. Let's solve this expression. It looks complicated. We've got open bracket, open parentheses, 4 plus 12 divided by 4, close parentheses, minus 2, close bracket to the third power. A lot of stuff going on there, but we're going to make it simple by following the order of operations. Any grouping symbols? In fact, there are. We have two sets of grouping symbols. We have the brackets on the outside, and we have parentheses on the inside. We always start working with the innermost grouping symbols first, so we're going to start with the parentheses first. Are there any exponents within the parentheses? No, there aren't. Is there any multiplication or division within the parentheses? In fact, yes, there is. We have a 12 divided by 4 we need to solve. 12 divided by 4 is 3, so let's rewrite the expression replacing that with 3. So we have open bracket, open parentheses, 4 plus 3, close parentheses, minus 2, close bracket, all to the third power. Is there any more multiplication or division within the parentheses? No, there isn't. Move on to the next step. Is there any addition or subtraction within the parentheses? Yes, there is. We have to solve for 4 plus 3. 4 plus 3 gives us 7, so we'll rewrite the expression. Now we just have brackets left. Open bracket, 7 minus 2, close bracket, all to the third power. We've completed all the steps for inside parentheses. Now we have to run through them again because we now have to work inside the brackets. First of all, any grouping symbols? Yes, we have left the brackets. Step 2, any exponents within the brackets? The answer is no. The exponent we have is outside the brackets. Step 3, any multiplication or division within the brackets? Nope. And the final step is any addition or subtraction within the brackets? Yes, there is. We have a 7 minus 2 we need to solve for. 7 minus 2 is 5, so we'll write down now 5 to the third power. Since there's only one operation left, we solve 5 to the third power. 5 to the third is 5 times 5 times 5, and that gives us our final answer of 125. Congratulations! You've learned how to use the order of operations to solve numerical expressions.